Hello, I'm Dr. Jeanette Stingone of the Department of Epidemiology here at Columbia University. This video is part of our machine learning series to serve as an introduction for public health scientists. I'm going to talk briefly about some of the future directions of where machine learning is going beyond some of the analysis techniques that we are familiar with. So, most of machine learning has been focused primarily on prediction, but there are a number of attempts and a growing field of integrating machine learning with causal inference techniques. On this slide, I have two books that I think are really helpful for people who are interested in learning more about this direction. The first is the Book of Why by Judea Pearl. And this book is really about why causal inference is important, why machine learning and artificial intelligence should be thinking about causal inference. The second book, Targeted Learning in Data Science, is more of an applied book to think about the use of targeted learning, which is a statistical technique that combines machine learning with causal inference in order to obtain causal estimates of effect in epidemiologic studies. So again, I think both of these books are good places to start if you're interested in machine learning, but trying to integrate it with methods for causal inference. So another advancement is the idea of using machine learning for data collection and harmonization. I think we're all pretty familiar with the use of machine learning for prediction and that type of data analysis, but it can and is currently being used in order to get better metrics of exposure to be used in research studies. This slide has one example, an article from Environment International, where street view images were analyzed with deep learning networks, and they created these images of segmented space. This allows the calculation and construction of metrics of green space. You could imagine doing this for other built environment features as well. These types of techniques are being used beyond sort of environmental epidemiology, can be used for the analysis of images in clinical settings, but also the use of computer science techniques for harmonizing data. So for example, if you have different studies that have different variable names, but they're measuring the same things, you can use computer science techniques and machine learning to understand that they're the same thing and harmonize across so you can pool your data more easily. All of these tools have the essential goal of making it easier to do the research studies we want to do with better metrics. And so that's a really exciting direction for machine learning to take. The last exciting direction I want to talk about is the investigation of algorithmic fairness and algorithmic bias. So when we think about our world according to data, right, it doesn't really represent the world as it should and could be. There's a couple of steps in between. We have the world as it is, right? And that world reflects all of the biases that separate what we want to happen with what is actually happening. But even there's still a gap to the data that we actually have, right? And the difference between the world as it is and the world according to data can be represented by non-representative sampling and measurement error. All of that then leads to the world according to your model. And again, there can be a gap, right? Even between the world according to our data and the world according to our model, based on how we ask our questions, the decisions that we make in determining how we build our model. We have a lot of techniques for these two things, for thinking about going from the world as it is to the world according to our model. We're not as skilled about thinking about the difference between the world as it is and the world as it should and could be. And this is really where this study of algorithmic bias, how these biases end up getting reflected in our models, but also algorithmic fairness. How can we create algorithms that truly represent the world as it should and could be, and help us use machine learning to help bring about that world? This figure is from a really nice review paper by Mitchell et al. In the Annual Review of Statistics and its Applications. And I think there's a lot of other readings in the literature that reflect this field of not just documenting that there are biases, but thinking about, can we bring about fairness using our algorithms? How can they help us in our quest to reflect the world as it should and could be. These are just a few of some of the future directions of machine learning, but I hope they get you excited and interested in learning more.